Hey, welcome to this explainer. We're going straight under the hood of modern AI models to tear down the master recipe that makes them actually helpful to us. If you've ever wondered how a massive cluster of GPUs just predicting text somehow turns into this polite, useful assistant that won't help you build dangerous things, you're in the right place. Today, we're breaking down the exact alignment stock that took us from the wild, early days of language models all the way to the highly refined, specialized systems of 2026.
So let's just dive right into the core dilemma here. Writing a math formula for helpfulness is completely impossible. Think about it. You can write a closed-form math equation for gravity or compound interest, sure. But helpfulness, you can't just map that over a sequence of words. It's subjective, it's contextual, and it's deeply human. So how do we teach a machine to optimize for a concept we can barely define ourselves? We needed a completely different approach. To wrap our heads around this, we're going to treat building an aligned AI like a recipe teardown. We'll hit the next token problem, the three-step RLHF recipe, preventing AI reward hacking, the pitfalls of reward modeling, and finally, the modern 2026 stack. All right, section 1, the next token problem, we got to start with the raw ingredients here. This really illustrates the massive gap we're starting with. A base model is trained purely to predict the next token across a ton of web text. And because of that, it writes perfect English. But it also lies, it rambles, and crucially, it refuses to refuse dangerous prompts. If you ask a base model how to hotwire a car, it might just enthusiastically write you a step-by-step manual. And here's the kicker. Throwing more of the internet's raw text at it won't fix the problem. It'll just memorize more of the web's chaos. We have to fundamentally change how the model decides what to say to get that helpful, safe model. Which brings us to section 2, the three-step RLHF recipe. This is where reinforcement learning from human feedback, or RLHF, steps in as the absolute hero. This right here is the exact three-stage pipeline that turned raw algorithms like GPT-3 into ChatGPT, and it shipped almost every aligned model you used between 2023 and 2025. It goes SFT, RM, and PPO. Let's break these down one by one, because they're the bedrock of modern AI. Stage 1 is supervised fine-tuning, or SFT. You start with your base model and fine-tune it on exceptionally high-quality human demonstrations of good behavior. This nudges the model toward acting like a QA assistant. But there's a catch. The model's action space remains entirely unbounded. It's pointed in the right direction, but kind of like an overly eager puppy, it can still wander off and say pretty much anything. It needs a way to mathematically lock in the rules. So here's the thing. Humans can't write a reward function from scratch, but we are incredibly good at comparing two things. We can easily look at response A and response B and say, yeah, A is better. In stage 2, we collect massive amounts of these human preferences and train a separate second AI called a reward model to mimic human judgment. To do this, we use the Bradley-Terry pairwise logistic loss. Sounds intense, but it just translates the difference in reward into a log odds of preference. Think of it like a chess ELO rating, but for text paragraphs. Every time response A beats response B, its rating goes up, letting the machine mathematically rank what used to just be human vibes. Looking at the timeline, it's pretty wild how this all builds logically. That Bradley-Terry math standard, it's been around since 1952. It wasn't until 65 years later, in a 2017 paper, that researchers proposed using those human preferences to train deep reinforcement learning models. And then bam, in 2022, InstructGPT shipped, proving this recipe could tame massive language models. We essentially took a concept from 1952 to fuel the absolute breakthrough of the modern AI era. But there is a huge catch. Let's move to section 3, preventing AI reward hacking. This brings us to the actual optimization in stage 3 using proximal policy optimization, or PPO. Check out this equation. On the left, R total is the final reward the AI gets. The first part on the right is the raw score from the reward model. But I really want you to focus on the very last part of this equation, the part that says minus beta times KL. That's the KL penalty. In the massive machinery of RLHF, this one little term is the single most important knob you can turn. Why does that specific math matter so much? Well, without that KL penalty acting like an invisible leash, the AI will absolutely find ways to reward hack. The reward model isn't perfect, it was only trained on normal text. Without the penalty, the AI figures out it can generate bizarre, out-of-distribution gibberish that somehow technically tricks the system into giving it a maximum score.
The KL penalty forces the AI to stay near the original human-trained reference model. It acts as a regularizer, literally like a sturdy rubber band, anchored to normal human language, making sure things stay coherent and safe while still maximizing the score.
Of course, no recipe is without its kitchen disasters. Welcome to Section 4, Pitfalls of Reward Modeling.
If you're building this stack from scratch, you've got to watch out for these major traps. We already mentioned reward hacking, but look at length hacking. Because human graders subconsciously prefer longer answers, the reward model learns to score long text highly. The result? The AI just endlessly pads its responses with total fluff to get a higher score. Plus, your reward model has to be physically large enough. You can't have a tiny brain grading a massive brain. You'll run into nightmares with KL tuning drift and PPO algorithms breaking down. And the craziest part? Studies show about 30% of human preference labels are just noisy or contradictory, meaning you're training a highly precise math system on really messy human data.
The classic SFD to RM to PPO pipeline was the undisputed champ for a couple of years, but things move fast. Let's look at Section 5, the modern 2026 stack. Today, the alignment stack is incredibly layered. We aren't using one single hammer for every nail anymore. Notice how, for general helpfulness, DPO has largely replaced PPO as the industry standard. But for raw capabilities like hardcore math or code, we use GRPO with verifier rewards. That means the reward comes from whether the code actually compiles, not just human vibes. For complex multi-step agent tasks, we use process reward models to score individual reasoning steps. And finally, for strict safety and refusal behaviors, we still rely on the heavy-duty RLHF PPO or constitutional AI. I really want to highlight DPO or direct preference optimization because this was a total game changer. DPO uses closed-form algebra to entirely collapse stages 2 and 3 into a single, elegant step. It completely gets rid of the expensive reward model and bypasses all the notorious headaches of PPO. It achieves the exact same alignment quality, but uses a fraction of the compute resources. It's just a brilliant evolution of the original RLHF idea.
And when it comes to the safety layer and how we actually scale all this, we've got to talk about constitutional AI, or RLHF. Remember how expensive and noisy human preference labels were? Well, to fix that, we now literally use an already aligned, highly capable language model to generate those preference labels. We give the AI a constitution, a strict set of explicit rules, and ask it to judge the outputs itself. It completely removes the bottleneck of human workers and vastly scales up our preference budget. Which leaves us with a pretty fascinating question to ponder as these alignment systems keep evolving at lightning speed. We started this whole journey relying on human feedback because humans were the ultimate judges of what helpfulness meant. But today, if we're increasingly using AI to generate the preferences, to train the reward model, and to align the next generation of models, who is really defining the reward? It's a profound shift in the recipe, and it's absolutely going to define the next decade of artificial intelligence. Thanks for diving into the alignment stack with me.